All right, guys, finally some new stuff in Chapter 4. Everything we've done so far has been a lot of review, but now we get to do something new. Now we are solving nonlinear systems of equations. And all that means is, if I scroll up a little bit, all this means is I still have two equations. If you look at the example, this first one, you have y equals x plus 2, and you have y equals x squared minus 2x minus 8. You still have two equations, but one of those equations that you have is a line. The other equation is not a line. It might be not an eraser. It might be a parabola, which means you're going to cross possibly in two different places. It could also be a circle. So you might only cross once. Well, in this case, I guess that pink line is going to keep going, huh? So you are going to still cross twice. But instead of two lines intersecting, you have a line intersecting something that's not a line. And it's usually going to be a quadratic, like a circle or a parabola, because that's what we're studying this year, right? We're studying quadratics. So, two methods of doing this. One on the left, one on the right. The one on the right is only for those of you that have a TI 84 calculator. If you have that calculator, you are welcome to try to do these problems graphically. However, we're not going to spend time in class learning to do it. You can read through that example. There are benefits as well as some limitations and disadvantages to doing it that way. We're not going to worry about teaching the graphic way of doing this because we don't have those calculators accessible to everyone. We are going to focus on the algebra, which is more fun anyway, because you're not just pushing buttons, you're actually solving a problem. So we're going to go through the algebraic solution. And I'm going to just kind of read through this example. It's already worked out. The math is already done. But there's a couple of steps that I want to point out, because really, you already know how to do the bulk of this problem. This is pretty much Chapter 3 all over again. You're solving a quadratic equation, which you got really good at in Chapter 3. But this time, there's one extra step at the beginning, and there's one extra step at the end. The solving the quadratic is just the middle piece. Now we've got to add a little bit to the front and back ends of that. So the steps that you go through, I have a system of equations, y equals x plus 2 and y equals x squared minus 2x minus 8. The first step is this one right here. It says to solve the linear equation. That means solve the one without an x squared for one variable. A lot of times that's already done. Like in this example, it's already y equals x plus 2. So we don't have to solve it. It's already solved for y. Step 2 is to substitute that into the nonlinear equation. So I'm going to take that x plus 2 and I'm going to plug it in right here for y, which is nothing new. You've already done that. You did that in the last chapter, or in the last homework. We took a value and we plugged it into the other equation. So in this case, I end up with x plus 2 on the left, because I replaced the y, and x squared minus 2x minus 8 on the right. Okay, this is where it goes back to Chapter 3. Okay, step 3 is to solve for x. My problem is I have an x squared involved, which is going to happen on pretty much every problem in this lesson. You are going to have an x squared. So we have to solve this like a quadratic, which was what we did in Chapter 3. And using quadratics, what we did is we used that quadratic formula and we also factored. That's how we solved for x. In this case, we're probably going to be able to factor this one. So what they did, and you don't really see this in the example, they took this x and they minused it to this side, and that became negative 3x. And then they took this plus 2 and they minused it to the other side, and that became the minus 10. So they just did their railroad tracks. They moved everything to one side so that it was equal to 0, because that's what you do when you're solving a quadratic. Then they did their big X. They put negative 10 on top. They put negative 3 on the bottom. And they said, okay, that's negative 5 and a positive 2, which means that x is equal to 5 and x is equal to negative 2. So I already know that my functions are going to cross. My equations have two different intersections. One of them is when x is 5. One of them is when x is negative 2. So now that I know what my x's are, step 4 is to plug those x's into my equation at the very beginning and solve to find my y value. So I take this 5 and I plug it all the way back into my y equals. And then I take this negative 2 and plug it all the way back in, and I solve each of those separately. And it does that for you up there in the example. But those are the 4 basic steps. Solve for one variable, substitute it into the other equation, solve for x, find your x values. Once you know your x values, plug them in, find your y values. So let's try that on a couple problems here. I think we're only going to do 2 on the video. We might do some more in class, in person. But number 1, y equals x minus 1, and x squared plus y squared equals 25. So I already have y equals, which is nice. So I just take my x minus 1, and I plug it in where I see a y. So my new equation, my second equation right here, becomes x squared plus, instead of a y, I've got to put parenthesis x minus 1, and it had a square on it. It was y squared. So I've got to do x minus 1 squared equals 25. Now I need to simplify so I can solve for x. My issue with simplifying is this piece right here in the middle. X minus 1 squared. Well, what that means, if I rewrite this as x squared plus x minus 1 times another x minus 1 equals 25. Right? Because x minus 1 squared means I'm timesing 2 of them together. Now I just have to FOIL. I have to take x times x. Well, let's drop that x squared down first. X times x, that's another x squared. X times negative 1, that's negative 1x. Now I move on to my negative 1 times x. Well, that's negative 1x. Negative 1 times negative 1 is positive 1, and that equals 25. So I got rid of my parentheses. I got rid of that square. Now I just need to combine like terms. X squared becomes 2x squared. Minus 1x becomes minus 2x. And then I still have a plus 1 equals 25. So I'm almost ready to factor or quadratic formula, but it doesn't equal 0. So I've got a minus 25 minus 25. So 2x squared minus 2x minus 24 equals 0. All right, now we can do our chapter 3 stuff, okay? Really, all we've done so far is plug in the y, simplify, move everything to one side. Now it looks like chapter 3. So I want to factor or use the quadratic formula. I don't care which one you do, but here's the nice thing about factoring. Remember when you learned to factor, the first thing you needed to look for is, does something go into everything? And that does, a 2. See how a 2 goes into everything on the left? What that means is I can take this entire left-hand side and I can divide it by 2. As long as I do the right-hand side and also divide by 2. The reason I want to do that is on the right-hand side, 0 divided by 2 is still 0. On the left-hand side, 2x squared divided by 2, well, that just becomes x squared. Negative 2x divided by 2, well, that's just negative 1x. Negative 24 divided by 2, well, that's just negative 12, equals 0. So all that did is make my numbers a lot easier to work with. They're nicer numbers, which we like when we're factoring. So I have what? X squared minus x plus, nope, not plus 12, minus 12 equals 0. So my big X, I put a negative 12 on top, a negative 1 on the bottom. what multiplies to negative 12, 4 and 3, but I need the 4 to be negative, so they add up to negative 1. Now, hopefully, you had the shortcut figured out before the end of the last chapter, because what I can do from here, I already know. One of my x's is going to be a positive 4. My other x is going to be a negative 3. Right? I just take the opposite of my big X values and it gives me my little x values. So x plus 4 and x x equals positive 4 and x equals negative 3. Now that I know my x's, I'm going to take those values and I'm going to plug them into my original equation. And I'm going to plug them into the one on top because it's a lot nicer to work with. So y equals 4 minus 1. So I'm going to plug in a 4 right there. And when I do, 4 minus 1 is 3. Well, that's easy. So when x is 4, y is 3. There's one of my answers. But I also need to plug in x equals negative 3 to the same place. So y equals negative 3 minus 1, which equals negative 4. So when x was negative 3, my y became negative 4. So there's my other answer. So that tells me that I'm going to cross in two different places. Sorry, I'm just trying to move some stuff here. My answer's 4, 3, and negative 3, 4. And what I want you to be really careful, because I know that the negative 3 and the 4, I know it looks like they all those numbers came from right here. That was just a coincidence. The x's came from my big X. The y values have nothing to do with your big X. They just accidentally came out to be the same numbers. Don't mistake that for always happening. It was just an accident on this problem, okay? And the reason it does that is this is actually a circle with radius 5. So it's a circle that looks like this. And my line crosses at 4, 3. So it crosses right here. And it also crosses at negative 3, 4. So that's what my picture looks like. It's not always going to look like that, but that's what this one happens to be. Okay, number 2. Same idea. Solve the system. Y equals x plus 4, y equals negative x squared. Well, I know that y is x plus 4, so I'm going to plug that in right there for my other y value. So x plus 4 equals negative x squared. Well, I almost have this set equal to 0 already. That was an easy one. So let's add x squared to both sides so that I end up with x squared plus x plus 4 equals 0. Now I can try my big X. I get a 4 on top and a 1 on the bottom. The problem is I can't think of anything that multiplies to 4 and adds up to 1, because my only options are 1 and 4 and 2 and 2, and those aren't going to work. So what that means is my big X method doesn't work on this problem, so I have to use the quadratic formula. So let's remind you what that looks like. X equals negative b plus minus the square root of b squared minus 4 times a times c, all divided by 2a. Most of you got really comfortable using this formula, so let's try it. A is equal to 1. B is equal to 1. C is equal to 4. So now I plug those into my quadratic formula. So x equals negative 1 plus or minus the square root of 1 squared minus 4 times a times c, all divided by 2 times a. And if you remember this, we're going to clean up the pieces. I'm not going to type that whole thing in my calculator. I'm just going to clean up those 3 numbers. So x equals negative 1 plus or minus square root. 1 squared is 1. 4 times 1 times 4 is 16. So 1 minus 16 is negative 15 divided by 2. And now I run into a problem. My square root has a negative underneath it. And that's not okay. That means that we have to use I, right? The only way to solve this is with imaginary solutions. We are not interested in solving a system of equations for imaginary solutions. We only want real solutions. So as soon as you see that negative underneath a square root, there are no real solutions. You can go back to saying that square root of a negative means there's no real solutions. And the reason there's not any solutions, what I have is a parabola and a line that never touch. That's what this looks like. Actually, the parabola is upside down and the line is higher up on the graph, but it doesn't matter. I have a parabola and a line that do not cross each other, so there are no solutions. And it'll look like a negative square root when you try to do it algebraically. Okay, when you do the homework, when you do these practices, they all look a little bit different. Like number 1, y minus x equals 0. Well, I don't want y minus x, I want y by itself. So I have to take y minus x and I have to railroad track and add x to both sides. So I end up with y equals x, which is kind of cool because you can plug that in right there for y. You plug in y equals x. So you get x squared plus x squared equals 32, and you solve that one is kind of unique. You might use the square root method on number 1. You don't have to, but you might want to use the square root method on that one. All of these problems look a little bit different, but you're going to follow the same steps. And I wrote them down over here on the right. So pause the video and copy down these steps. Step 1 is to substitute. You got to find y, plug it into the other equation. Step 2 is to solve for x using the square roots, using your big X or the quadratic formula. Step 3 is to take your x values, if you got any, and plug them in to find your y values. And then step 4 is to write your solutions as points, x, comma, y. Good luck.